Linus, and I thought it would be a good idea to do a video on his build, or his skeleton, to show you what he's made out of, and what things were necessary so that he could run properly, and the thought process around how to make him. So first off, I'd like to say that the chassis that we used is the Magician chassis. The sort of URL will be somewhere on the screen. And we just ordered it off Sparkfun.com. So we just put together the chassis because we thought that would be easier. And conveniently, it came with a 6 AA battery pack that we double-sided tape stuck on to the top of the chassis. And then we cut back the wires and soldered on a DC jack that fits right into the Arduino. So speaking of the Arduino, this is the Arduino. It's actually not mounted to the chassis. We felt that, we didn't really need to mount it. And what you're seeing right now is actually the shield that we made so that we could run the motors easier than having sort of a small breadboard or what have you. What I'm going to do now is I want to give you guys a closer look at the shield in particular, and so that you guys can sort of see how we went about it, and you can relate it to the fritzing image on my blog. Alright, so what we have here is our just regular Arduino Uno and our motor shield. So as you can see, like all motor shields, it's designed so that you can just take it and sit it right on top of the Arduino, and if you need more than one motor shield, you can actually stack them on top of each other. Obviously it would get kind of hard because the pins would get limited, but it is possible. So for right now, we're not focusing on the Arduino, we're focusing on the shield. So from the top view, you can see that we filled in all of the female pin headers, and we actually added some right on the top here. So these two pin headers right here are actually to drive the wheels. They are fed the power and ground from the H-bridge, and so this side would control the power ground of the left wheel, and this side would control the power ground of the right wheel, or vice versa, depending on how you wire it. And so you just simply plug them in. Now obviously we only really needed 2, but since they come in a string of 5 and they're pretty hard to break apart, we decided just to leave them on as 5. So like I said before, this is our H-bridge that we soldered into the shield. But we actually didn't solder the H-bridge directly into the shield. We soldered, if you can see there, it's actually sitting in a chip seat. So we soldered the chip seat into the shield, and then we just put the H-bridge into the chip seat. So you can actually take the H-bridge out, which we did, I think, 1 or 2 times because we thought that may have been a problem when it wasn't working. And in, I think, one case it was. So that was very handy, because if you had to unsolder everything, that would be a huge pain. So I highly suggest using the chip seat. What's a good angle that you can see that in? That looks pretty good. You can see that there. You can see how the pins aren't actually going into the shield. They're sitting in the seat. Okay, so on to the underside. So this is the bottom of the Arduino shield, and it looks ridiculous with the amount of wires. However, this problem is unavoidable because the way the H-bridge is designed and the pin layout on the Arduino, you will have to jump wires from one side to the other. So whichever way you do it, you're going to have to be jumping, and it's going to look like this. But it wasn't too bad. The actual layout for how we soldered this shield is on my blog. It's a fritzing image, and it helped a lot. It's nicely detailed, and we followed that exactly, other than actually mounting the female headers. But that's pretty straightforward. You just take the power and ground off the H-bridge and put it onto the female pin headers. Okay, so that was the overview of the Arduino Shield. Now I'm going to show you guys the circuit board for the sensors. Alright, so here is our sensor board. What we are looking at right now is actually the underside of it, because the sensors would be facing towards the ground to be reading the line. And as you can see, each sensor has a 10k ohm resistor and a 150 ohm resistor, along with an analog read jumper cable. All of these jumper cables connect to these 5 curved male pin headers, and these 2 curved male pin headers are the power and ground to the circuit board. These curved pin headers were actually very important because you want the sensor board at a specific height, which is generally pretty low to the ground. Using regular male pin headers, I think you can see it better like this, they're actually too tall and they would be dragging on the ground when Linus tries to drive. So as you can see here, they're curved and they stay really flush to the actual circuit board. So it helped out a lot and we could get a lot closer to the ground. Okay, so looking at the underside, you can tell that we numbered each sensor 1, 2, 3, 4, 5, so that when we're calibrating them through the Arduino program, we can tell which sensor is which obviously is very important. You can see our 5 analog read male pins. They're not connected because they're jumper cabled on the other side. And then our power and ground. And then each of these would be the sensors, with this being the general ground bar and this being the general power bar. The full schematic along with the board layout is on my blog. It's in the Eagle format. It's just a picture. I didn't upload the files, but I'm sure that if I feel it's necessary, I can upload them later. So this was our board. This was the shield, and this was the body, the now dismantled body of Linus. So I hope this video helped in sort of the creation, or in this case deconstruction, of Linus. And now I'm going to flip over and sort of talk about the calibration of Linus, why we designed him the way we did, and just sort of some general tips if you're trying to recreate Linus. Okay guys, Happy New Year, I guess, since I'm seeing you for the first time. I'm going to talk about the calibration and sort of tips on if you're making your own Linus. So to start off, the calibration. The calibration is what we found preferably done before every time you run Linus. It's very tedious. You have to go through each sensor, so 1, 2, 3, 4, and look at its raw value through the serial monitor. There's a piece in the Arduino code that I posted where it shuts off the motor power, so you're only reading the sensors and not worrying about the car driving around. So what you're doing is you're just adjusting the min value and the max value. So you're going to put sensor 1 on black, and that'll be your min. You're going to put sensor 1 on white, and that'll be your max. Then you're going to do that for 2, 3, 4, and 5. For the room you're in, or if you turn on a light or anything, I don't really think shadows aren't so much a big deal, but definitely the room you're in matters a lot. So that's calibration. The other thing is sort of tips. Big tip, the height of your sensor board to the ground matters a huge amount. If it's too high, it won't read the line, and if it's too low, it won't read the line. So you have to just keep testing over and over again to see what the perfect height is. And you know, there is a little bit of wiggle room. Obviously these standoffs aren't the perfect height for these sensors, but it works pretty well. The other thing is batteries. If you find that your wheels one is going slower than the other, or if it's spinning in circles, it's probably due to the batteries, so try changing them and seeing if that helps. If not, recalibrate the sensors. If that fails, always, constantly run your finger along it and see if the wheels are moving in the correct fashion. And another point that I actually never mentioned was the caster wheel on the bottom of Linus. So we used a caster wheel in the back so that it can move any way and direction doesn't matter. This allows us to only use two motors instead of 4, but you can use 4 if you want to. You would just wire the power and the ground to the same motor female pins in your motor shield. But this would mean that you would need more than 6 AA batteries because you're now driving 4 motors instead of 2. So that was a quick calibration talk and sort of little tip thing. I explain it in a lot more detail on my blog, so go there to read up on it. Also, I explain the code. I know I didn't explain the code in a video this time. It's because this video is already really long and the code is insane. So overall, great project. I really like this one. Autonomous robots are really fun to watch after you're done building them, and you feel great because it's like you gave this thing a brain, which is pretty cool. So yes, head over to my blog, check out all my write-ups and my fritzing diagram, my eagle diagram, the code, the explanation of the code, the libraries. You need libraries to run the sketch. You can download them on my blog too. And I linked a page to the Arduino website that tells you how to create your own libraries and also how to add them, which you need to know how to do if you want to run the sketch. So thank you for watching, and next ER is undecided. It probably won't be for a while because we're starting infrared, and that will be a hefty task. So thanks for watching, and I'll talk to you guys next ER.
Dunno really. Oh, if it's on, I'll listen to it. Loud guitars, tattoos, anything else is a bonus.